Okay, so this video is just to show you give you some ideas for what you could possibly do for rates of reaction experiments, and also the errors, some major common errors to avoid. So gas pressure, mass, color, pH, conductivity are some of the things you could possibly do. The big one with collecting air is collecting a gas is making sure you know what sort of gas and whether it's going to have an influence on the setup. So hydrogen gas, it's good to use this particular setup because hydrogen gas is lighter than air and it will actually collect. So you need to make sure it's above and it collects in this particular way. Another one to be careful of is if you're collecting the gas over water, so you're letting it bubble into the solution here. That's fine for hydrogen, but it's not good for water-soluble chemicals like ammonia, which you probably shouldn't be collecting anyway. But you should just have a quick double check of how soluble that gas is in the liquid. You also need to think about partial pressures, which adds a lot to the complexity of this particular experiment. So the water itself is actually, water vapor is actually coming off as well and adding to the total gas volume in here, and you need to do a partial pressure equation for that. You also need to worry about the warmth of the liquid itself reacting, and also you can even get steam coming in here, so there can be all sorts of issues going on with these sorts of things. Change in mass, a classic one that students might not be aware of is hydrogen is a super light gas, the only gas I think that actually escapes from the atmosphere. But if you're doing something like carbon dioxide, that is extremely heavy. That's like 44 times heavier, literally, well, not because that's 2, 10, 20 times heavier. So it's quite a difference, and you really need 3 or 4 decimal places or Mettler balance, because you're not going to be able to detect something. Just a 0.2 is far too crude. Okay. And then we're changing color. This is definitely for senior chemistry the one to do. You can pretty much do any chemical reaction whatsoever and there will be some sort of indicator and a light indicator. It is very quick and easy, and it's very easy to get the time. That is definitely the winner. Okay, so if you can use calorimetry or spectrophotometry, they do cost a little bit, those data loggers though, 300 and up, but definitely worth it. And this one would come in as a very close second. I would highly recommend a drop counter. Do not try and do a titration yourself. You're not going to get a range of 5, repetition of 3 that way. It's going to take too long. You can sort of get out of it by using a multimeter to use conductivity or a pH meter, seeing how to put that sort of up to your design. And lastly, one to definitely avoid is the clock reaction, because you have to wait for something to occur before you can measure it. You can't measure it over time, so you're not going to get the average rate you're going to be stuck with an average rate of reaction rather than an instantaneous initial rate of reaction, which controls your concentration. The fact that your concentration and temperature changes straight away, and so the temperature and concentration is not controlled. So try and avoid average rate of reaction. Try and get a nice curve and do the instantaneous rate of reaction. That's the tangent to the curve right there, which I've talked about in a previous video.